Hi everyone. Today we will be looking at the problem Book of Poetry from POI 2018 round 2 day 2. You have n poems that you want to publish. You have to publish them as a book, and each book has multiple pages. In each page you can fit up to s lines of text. Now the poems are printed one after another with no empty lines between them. Each poem consists of a title which occupies one line, followed by the actual content which takes AI lines for the ith poem. However, there is a catch. It is given that for sake of aesthetics, a title of a poem cannot be printed in the last line of a page. So if a preceding poem ends in the last but one line of a page, the last line has to remain empty. So we will call them as interior empty lines. Our objective is to minimize the number of such interior empty lines. So we are given the number of such books. So we are given the number of poems n and the number of lines of text each page can fit, which is given by s. And we are given the n poems, they are up to 10 to the power 6, and s are also up to 10 to the power 6. And this is the example that is given. So in the first example, there is one empty line of text. In the second example, there is no empty line of text. So let's try to reduce the problem. The first observation here is the extra added header line. You can just include it in the body of the text as well, and you can just say that a new poem cannot start at the last line. I mean, the title and the body doesn't really make a much of a difference. You can just take the whole thing to be the body. So the first thing that you should do is you should add 1 to all of these numbers. So 35251, it essentially becomes 362, and the number of such numbers n was given to be 3 and s was given to be 5. Now it should also make sense that you will want to take modulo s for all the length of the poems that are given, because I mean then it's effectively just skipping a page, right? If your length is greater than s, then you are just effectively skipping a page. Skipping a page can come in many forms. It can be like you started, let's say, from here, and then you wrote over the entire page the same poem, and then you ended somewhere like this. So that means this is an entire page that you skipped. Or it can be something like you started, let's say, here, and you keep writing, and you end up here, right? So effectively everything down below this portion and everything up here this portion, this total part effectively sums up to s. And even if you did not do this portion, like the entire of this portion, if you did not write, then also relatively where your text ended still remains the same. So taking modulo s seems intuitive. So here, for example, this transforms our list into 3, 1, 2. Now what does this 3, 1, 2 effectively mean? It means that if you started your text at, let's say, line number L, so let's say this was your entire body, line 1 there was some text, line 2 there was some text, you started your poem at line 3 and you write a poem of length 2, then 3 after 3 plus 2, this will be the position where you start your next poem. So you place a poem here, you place a poem here. So effectively we are kind of maintaining a pointer to the next position where a poem should start. So now we can rephrase our problem in the following way. We want to add to our pointer all the values ai. So this is the set A. So we want to add to ptr plus a1, then we want to add plus a2, then we want to add plus a3, where a1, a2, a3 is some permutation of the set, such that the number of times where ptr plus a1 plus a2 plus dot 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 aj, and again you have to take the mod because you are storing the relative position from the start of the page. So once you cover the entire page, it does not really matter, you just want to store where from the start of the page you are, and you have to ensure that this does not become equivalent to s minus 1. What will this mean then? Because this value is the new ptr, it will mean that ptr new is at the last line of a page. S minus 1th line is the last line. So you don't want ptr new to be at the last line of the page, because remember that ptr new is where you should start your next poem. Since you cannot start it at the last of the page, that means every time this happens, your counter, so let's say ctr denoted number of empty interior lines, then you just do ctr plus plus. So you have to minimize the number of times this happens. Keep in mind that when I say a1, a2, a3 up to aj, I mean a is a permutation of the initial array. So if this was 3 1 2, we could have inserted like 1 2 and 3, so on and so forth. Now how do we do this? Well, the intuition is that you want to add something so that the diversity of the values remains the maximum. So what do I mean by diversity? Diversity is the number of unique values in AI, in the set A. So the idea is that, let's say you can add some AJ to PTR, but this would have resulted PTR to become S minus 1. So you don't want to add AJ, you can take any other value, let's say AK, and you add that to PTR. This will ensure that PTR does not equal to S minus 1. So our algorithm becomes like this. In every iteration, choose AJ such that diversity is maximum, add to PTR AJ. Now if this does not become S minus 1, then you are fine, just go to step 1. If a PTR becomes S minus 1, then don't add AJ, pick something different, pick AK such that AK does not equal to AJ, and out of all the choices for AK, so out of all choices for AK, pick the one which maximizes diversity. So again, our central goal is kind of to maximize the diversity, right? Every time we pick our numbers with this in mind, this kind of ensures that you are not utilizing up everything, so that when this case happens you don't have any other AK. You always want to have some substitute AK that you can replace it with, so that you don't hit S minus 1. Now as long as your diversity is maximum, you are kind of guaranteed that the best case scenario for having as many substitute values as possible is always true. Now as long as your diversity is maximum, it is good for you, because that means there are going to be multiple substitute values for the AJ, which is AKs. And out of all the AKs that you choose, you again want to make a choice such that it keeps the diversity maximum. So anyway, so as long as you have a substitute AK value, this S minus 1 will not be hit and you can continue doing your algorithm. Now this diversity is maximum is still a bit vague, right? What do I mean by diversity is maximum? Number of unique values in A, there can still be multiple ways to pick unique values. What we will go for here is, by diversity being maximum, I want to mean that we will take AJ or AK such that frequency of this AJ slash AK is maximum. Frequency of AJ or AK is max. So intuitively, let's say I have sorted everything by decreasing frequency. As long as you keep taking the one from the highest frequency, so after you take this becomes a bit shorter, after you take shorter, and then this is no longer the max frequency, you take from this pile. So these pile corresponds to 0, 1, 2, 3 up to S minus 1, and you take from these piles whichever has the maximum frequency. This kind of ensures that, so this ensures that you will have max diversity for as long as possible. This is also very important. You want to have your diversity at the maximum for as long as possible. I mean, at this scenario, you could have just taken from anything from here, and the diversity would have remained the same. But then, if you keep taking from something smaller, then at some point, you will soon realize that everything, let's say, there is this huge tower. So this tower effectively means that the frequency of some item AI is very high, and for all the rest of the items, you just have AJs. So that means now every time you pick an A case from here, your diversity decreases. But instead, if you had utilized more of this AI, then it would still have been a bit longer. Then even taking here would not have decreased your diversity. So that is what I mean by keeping the diversity maximum as long as possible. So this is our final algorithm. Instead of saying that max which maximizes diversity, we pick AI, AJ, AK, whatever, which has the maximum frequency. If that choice leads us to add S minus 1, then we don't take that choice, we take the second highest frequency number and we continue our algorithm. Now at the end, when there are no more substitute values left, then you just have to keep adding the ages. Claim is that it won't be worse than whatever some other optimal solution might have been. The only thing that we should take care of is that while adding zeros, so there will be a bunch of values where AI equal to 0, right? We should add these zeros at the beginning instead of keeping these zeros for the end. We should add them at the beginning. Again, I claim that that is not worse than what you could have achieved, because zeros effectively don't change your PTR, right? But imagine this, what would have happened that if you are at PTR equal to S minus 1, you keep hitting these zeros. That is bad, right? Because then you will be increasing your counter much more quickly. The better way to do it is, if you add them at the beginning, then it's just as if you are utilizing some full papers at the beginning, and then you can still start at the top of your paper. So let's just quickly look at the code for this problem. I'm taking the inputs, increasing them by 1, taking the mod, calculating the frequency, and for every value modulo s, I am also storing a list that which all actual values had that same modulo. Then I'm pushing everything into a priority queue, which is a pair of the frequency of I and the index itself. I am using the less II comparator so that our priority queue returns as the element with highest frequency. Note that II is just representative of pair int comma int. I am first keeping the sum. So sum is just the PTR variable that we discussed. I have renamed it as sum here. So I am taking sum as -1 because here, as I have coded it, I am using the sum variable to kind of point to the end of the last poem instead of beginning of the next one. So that is why, let's say if we add 3, we would have entered at the point 2, which is correct because your poems would have covered the lines 0, 1, 2. The next poem effectively starts from the next line, which is sum plus 1. That is what I have checked here. If e.ss, which e is basically the next element in the priority queue, ss means the index. Here index is just what is the modulo value that we want to add. So if we see that after adding it we get s minus 2, because note that in the discussion we just had, I was referring to the pointer at the next position where the next poem started. That could not be s minus 1. It is exactly the same as saying that the place where the last poem ended cannot be s minus 2. So if that is the case, I don't take that element, I take something else. So here again we have two cases. If the priority queue is not empty, then we can take the next most frequent element. However, if the priority queue is empty, then there is nothing that we can do. So we just add the element as is. And if this is not the case, then we can again just add the element as is. After that, we just check whether sum equal to s minus 2 or not. If it is, then we have to do ctr plus plus. Note that I am also checking whether the priority queue is empty or not, because if the priority queue is empty, that means all my poems have been exhausted. Then that last line would not have been counted as an empty interior line. That is also mentioned in the problem. And then we just output the counter and then the order of the books. So that was the problem, Book of Poetry. Hope you like the problem. That's it for today. Thank you.